Welcome everyone, and this is the fourth tutorial part about neural networks with one hidden layer. We came to the last tutorial part where I'll build a neural network's final model, and for our neural network's final model we'll use all previous functions, so we'll place them in the right order. So the same as I did in logistic regression tutorial series, I will need predict function and model function. So to make everything easier and faster, I'll just simply copy this from final code. It is there, and in this code I'll just modify this code, and here is the predict function and the model function. So at first I'll modify our predict function, and only then I'll move to final model function. So I copied it, by the way, from my website where is final logistic regression tutorial. And what I need to do before I forgot, I should uncomment the functions where I read, for example, my images. I reshape it to where I prepare my data set in the right shape. So the shape would be here is the image pixels, and here is number of images, and here is I, so it is 0 or 1 in our 6002 examples. So I move to my predict function, and here it will be a little bit different. We'll use parameters and x. So here, the same way as I did before, I will need I prediction, and here will be my numpy zeros the same way, but right now I'll make it a little different, so it will take less space. I'll just copy m here, and I will remove this. So now I have a few more lines, and here we did a forward propagation. Same I will do now, and here I'll just write that we'll need a2 and cache what we did in our forward propagation. So I'll just add this function, and here simply will be my x and parameters. So, and I leave this as before because, well, actually we are trying to predict same dog or cat, so I leave it as it is. And now, yep, just I finished my code in a matter of minute or two. So explanation took more time than modifying it. And now I'll move to my neural network model, so I'll give it a different name. So now it will be neural network model, and here I'll just also make some modifications. So now it will be x train, I train, same as it was before, but instead here I'll add a hidden layer. So our hidden layer will be called like that, and here will be my number of iterations. As default I'll set 1000. For learning rate as default I'll set 0.05, and print cost will be default as false. So same as before, we made an initialization here of parameters, so I will do the same. So I'll write parameters equal to initialize parameters, just like that. And here I'll use my, for example, yeah, I'll write it a little bit in simpler way to understand. So it will be an x will be equal to x train dot shape of 0, and another parameter, this is our first layer, so number of pixels in our first layer shape, and here will be my output. So output will be I train and also the shape. So this is, I don't know, a lot of pixels, and here I'll just write input. So the input will be and X. Then will go my hidden layer, and my output layer. All three layers. And here is our middle layer, what we are doing in our tutorial. So right here we initialized layer. I can remove this for now. And now here was our gradient descent function, so I'll just make it a little different later. Now what I'll need to do is I need to get back my parameters as before. So I should retrieve W1, B1 as before, and I'll do the same with my W2, B2, W2 and B2. And now we'll write our for loop. So as I said, it will be a little bit different than before, because before we had this optimization function which we used. So right now we'll just write optimization function here. So it's quite not that different, and I could copy my optimize function, but will be much faster if I'll just write it here. So here will be my for loop for I in range of 0 and number of iterations. I will call few functions. So at first we should do our forward propagation. So I'll just write forward propagation as our inputs will be just x string and parameters. So we do our forward propagation with inputs for our parameters. Next we have to calculate the cost. So cost will be compute cost, and we wrote this before. And here will be our A2, I train, and of course again parameters. And here we receive our cost, and when we have our parameters and the cost, well, and the cache, we can do our backward propagation. So gradients will be equal to backward propagation, just like that. And here I'll just write parameters. Then it will be a cache, then goes x train, and of course I train, just like that. So we have forward propagation, cost calculation, and backward propagation. What is left? So we need to update our parameters. Parameters will be equal to update parameters, and here I'll give parameters, then will be our grads and our learning rate we are using. So I think that's it. We wrote a whole loop for it, and what I'll need to write more, so we would like to print our cost, that we could track how it's trained. So I'll just write a simple function here, if print cost, for example, and I divided by, and I divided by 200 iterations, it will be equal to 0. Then print, then we'll print that our cost, for example, cost after iteration dot, just like that. And sorry, not that sign, F, and here I'll just add I and cost. So we'll print our cost every 200 iterations, And next we would like to use this. So I'll just modify again our predict function. So here is our parameters now, and we calculate everything the same way. And here is also numpy mean, abs, prediction train, and I train multiplied by 100. Yeah, everything is the same. Here I'll just, right now we don't move this anymore. We did this only in our first logistic regression tutorial, and right now I'll write parameters. And now, as we have finished, for example, we finished our model. Now we just want to write it for one example, train our model, for example. So I'll write parameters. Well, actually, I don't need this. So I'll just write neural network model, and here I'll just add well, why I'm writing this, I don't know. I'll just copy it from my logistic regression tutorial. This is only one line of code. Just give me, I'll just find it. Okay. So here's the line from my logistic regression tutorial, and I'll just write it as neural network model. We'll use the same data set, and here will be our hidden layer. So I'll just add it like that, and for my example I'll use, for example, 10 units. 3,000 of this will be, here we will use 5, learning rate of 0.005, and yeah, that's true. We would like to print it out. So okay, we can save it and try to run it at last. So right now it's loading dataset into the memory, and in a shortly it should start training. So I'll leave it for a moment and I'll come back in a moment. So sorry, and as I see I have an error here. What I wrote wrong here, I don't know. And yeah, I wrote it in a bad shape. Okay, let's build it again and we'll see. And the same way as I did before, right now while it will be training and loading, I can write a best choice function. So before we were using best choice of learning rate function, and now we'll write a best choice of hidden layer count function. So in our logistic regression we compared results with different layer rates. Okay, we have another error here. Let's see. This was a smaller W, so I wrote it somewhere a bad shape. Let me find it. Okay, it's here. Okay, let's build this. As I told, neural networks are able to learn even highly non-linear decision boundaries, unlike logistic regression. So this time we'll compare the hidden layer count of our model with several choices. So I'll write a code, so you can feel free to try different values. Then I will, and try it by yourself. So at first, to make it everything faster, I'll just copy the code from my logistic regression tutorial last part. So if you haven't checked it yet, you can check. And okay, I'll just, here it is. And right now, okay, we have another error. That's amazing. So here, grads. Where's my... oh, here. Yeah, here should be grads, and yeah, let's try it again. And as before, I started, so I copied here my function, and now I'll just change this to hidden layer, and now we'll use, for example, I don't know, 10, 50, what here, 200 I mean, and 400. And now we loop it here, and we'll change this. And now hidden layer, learning rate, hidden layer is count, something like that will be. And what else I need to change? I'm thinking something wrong is here, I think. So let's wait for our another input and we'll see. But yeah, anyway, I'll fix it because I'm writing here in real time everything. It's quite hard to track all mistakes I can do. So let's wait for another iteration and we'll see what we have. And while it's doing something, I'll just double check the code. Okay, initialize parameters, just like that. Okay, cost, compute cost, A2, iTrain parameters, grads, backward propagation parameters, cache, xtrain, iTrain, and here parameters, update parameters, grads, and learning rate. Well, everything seems fine, it's working, but I don't know why. Cost after iteration 0 is insane. Well, we'll see what we receive it later. So anyway, here what I'll do, I'll just, instead of this model, I'll copy here this model, and here in our example, while we will try 5 different hidden layers, I'll write that, for example, will try it for 10,000 steps, learning rate, okay, well, we'll try it with 0.1 learning rate, and instead of 10 hidden layers, we'll write it as I, just like that. And yeah, I think everything will be fine here, and later when this finish, I'll start this model. So finally, I can say that we actually finished our another tutorial series about neural networks with one hidden layer. And if you'll test this code by yourself, you might say that it's not that different from our logistic regression code, but to teach our model to recognize cats versus dogs takes a really long time, because as you can see, it even didn't started it didn't even finish 200 iterations with simply 10 hidden layers. That's crazy. So the time needed to train model compared with accuracy is not worth it. So in our next tutorial series, we'll start building deep neural networks, and we'll refuse to using a sigmoid inefficient function, because as you can see, sigmoid is very computationally not efficient, so we should avoid of using it. And here as we are using another hidden layer, it takes a very long time. So anyway, I'll post everything here on my text version tutorial, and when this code will finish, I'll upload the graph, what I receive of these different hidden layers, what will be the results, and I will compare them, but not in the YouTube tutorial. So sorry, but well, it will take very long. I do not recommend you to use this for 10,000 steps and with 400 hidden layers, but I will do this for science. So I'll leave it for night or something like that to compute, and this will be finished. And moreover, it might be slower because I'm recording a tutorial right now. I don't even know how well it will be recorded with quality, because the CPU is eaten a lot, and we'll see. So to get more experience with this model, you can test performance on different datasets. Neural networks with one hidden layer might work better on tasks where we don't need to recognize objects from images, so as I am doing here, cats versus dogs. So moreover, you can try playing with learning rates or different number of iterations and test it by yourself. It's up to you. And I should say that that's it for our one hidden layer neural network tutorial series. And right now I will start with more serious stuff. So I will start building a deep neural network with NumPy. It also will be step by step. So I recommend you to learn it, to adopt what I teach there, and you'll see that I'll use different activation function, not a sigmoid. I will use a ReLU because it is much more efficient, and yeah, you'll see how it works. I don't know by myself yet, but we'll see. So thank you all for watching. I should say subscribe my channel, like this video of course, and share it. Then I'll be able to create more of these very interesting tutorials. So it's very good to learn these NumPy basics. So that's it. Thank you all for watching. Good luck and see you in our next tutorial.